We are going to look at the laws of exponents. This is a review. Okay, so an exponent, we have 3 to the 4th. So we have 4 3's multiplied together to give you 81. Okay, exponents. So here we have a power. The 5 is the base, and the 3 is the exponent. So 125 equals 5 to the third means that 5 to the third is the exponential form of the number 125. So 5 to the third means 3 factors of 5, or 5 times 5 times 5. Let's take a look at our basic terminology one more time. Exponent. In exponential notation, the number of times the base is used as a factor. Base. In the exponential notation, the number or variable that undergoes repeated multiplication. 2 to the 4th. What is the 2? That's right, the 2 is the base. What is the 4? That's right, it is the exponent. So what this means is that we take 2 and we multiply it by itself 4 times for 16. Okay, here are some important examples. Notice the negative 3 to the 4th means that you have a negative, then in parentheses you are multiplying 3 by itself 4 times. So notice that the 81 is still a negative. However, if you have a parentheses with the exponent of 4, what it means is that we are multiplying a negative 3 times itself 4 times. Notice how the 81 is positive. So negative 3, that is to the third power, means that you have a negative on the outside, you're multiplying 3 3's together, and so you have a negative 27. A negative 3 in parentheses to the third power means you have negative 3 multiplied by its to negative 3 3 times, but notice you still get a negative 27. And the reason why is because that is the difference between even exponents and odd exponents. Even exponents, if they are in parentheses, will always give you a positive number, while odd exponents will always give you a negative number. Okay? Let's take a look at the laws of exponents. The first law is exponential form. The exponent of a power indicates how many times the base multiplies itself. So if you have x to the n, that means we have n factors of x. So our example, 5 to the third power, or 5 cubed, is 5 times 5 times 5. Second law, multiplying powers. If you are multiplying powers with the same base, keep the base and add the exponents. The general law looks like this. Notice how your bases must be the same, and we just add the exponents. Let's look at some examples. So if we have 2 to the 6th times 2 to the third, then we just get 2, and the exponents add together as 6 plus 3, which is equal to 2 to the ninth. So notice our student here thinks he understands it. Now we're going to look at dividing powers. When dividing powers with the same base, keep the base and subtract the exponents. So if you have x to the m exponent divided by x to the n exponent, please notice the base stays the same, but your exponents subtract each other, the top from the bottom. Let's take a look at an example. So here I have 2 to the 6th power divided by 2 to the 2nd power. So 2 is my same base, so I have 6 minus 2, which is equal to 2 to the 4th, which is equal to 16. Okay? So when you divide powers, you're going to subtract the exponents. All right, we're going to look at some examples here. And instead of having a lot of questions, I'm just going to pause the video and you'll just answer them. So 3 squared times 3 squared is going to give us what? So we just add the exponents. They becomes 3 to the 4th equals 81. What about 5 squared times 5 to the 4th? What answer are we going to get for that? So I get 5, 2 plus 4, which is equal to 5 to the 6th. What about this one? I have a to the 5th times a squared. So I'm going to have a5 plus 2, which is going to be equal to a to the 7th. All right, now we're going to continue to get more complex. So we have 2s squared times 4s to the 7th. What is going to happen here? That's right, I'm going to get 2 times 4 times, and then the exponents are just with the s, so they get added together. So I get 8s to the 9. Let's take a look at this. Even though they're -3, I still get 2 plus 3, which is -3 to the 5th, which is a -243. Let's take a look at this one. What do you think it will be? That's right. We're going to have s 2 plus 7 and t 4 plus 3. So it's s to the 9, t to the 7th. Just a few more to make sure you understand what's going on. Let's do some division. So we have s to the 12th divided by s to the 4th. What are we going to get? S 12 minus 4 is equal to s to the 8th. I have 3 to the 9th divided by 3 to the 5th. What's going to happen? That's right, I'll get 3 9 minus 5, which is then equal to 3 to the 4th, which is equal to 81. Look at this. We have s to the 12th, t to the 8th divided by s to the 4th, t to the 4th. That's right. We're going to get s 12 minus 4 times t 8 minus 4, which means we have s to the 8th, t to the 4th. Let's look at our last example. We have numbers as well as variables. What's going to happen here? We're going to take the 36 and divide it by 4. We'll have a to the 5th minus 4, b to the 8 minus 5. So I get 9ab cubed. What other laws do we have? Here we have power of a power. If you are raising a power to an exponent, you multiply the exponents. Okay? So this is what's going to happen here. Let's take a look at some examples. So if I have 5 cubed in parentheses to a square, then the two exponents are going to get multiplied together. So I'm going to have 5 to the 6th power. They get multiplied together. So you have to be careful on this one. So when I take a power to a power, I multiply the exponents. That is correct. Okay. The product law of exponents, if the product of the base is powered by the same exponent, then the result is a multiplication of individual factors of the product, each powered by a given exponent. What does that look like? So it means that when you have multiple variables or numbers in a set of parentheses being taken to an exponent, this exponent must be distributed to everything that is inside the parentheses. Let's take a look at an example here. So we have AB that's going to be squared. Notice how it becomes a squared times b squared. So when you take the power of a product, you apply the exponent to all the factors of the product. The quotient law of exponents. If the quotient of a bases is powered by the same exponent, then the result is both the numerator and denominator, each powered by the given exponent. What does this mean? Again, it means that your exponent will be distributed to both the numerator and the denominator. Let's take a look at what this means. Notice how you get 2 to the fourth divided by 3 to the fourth. So the power, the exponent of 4 is distributed to both the 2 and the 3. So when you take a power of a quotient, you apply the exponent to all the parts of the quotient. Let's practice these. What is the first one going to be? 3 to the 10th. What is the second one going to be? That's correct, a to the 12th. How about this one? What happens here? We're going to get 2 cubed, and the a has a square, so that's going to be square times the cube. So we'll get 8a to the 6th. What about this one? What happens here? So we get 2 times 2 as our exponent, a 5 times 2, and then b 3 times 2. And when we multiply all that, we get 2 to the 4th, a to the 10th, b to the 6th. Now, notice how we do take 2 to the 4th and multiply it out. Let's take a look at this example. So we have a negative 3 squared times a to the exponent of 2 times 2. So our negative 3 will become positive, and we'll have 9a to the 4th. Let's take a look at this. The 3 is distributed to both the s and the t, and then multiplied by the exponents they already had. So we get s to the 6th, t to the 12th. All right, now we have a quotient. What's going to happen here? That's right, we get s to the 5th over t to the 5th. We have another quotient with exponents inside. What do we do first? Well, first they actually subtracted what was inside the parentheses. 9 minus 5 is 4. Then they multiplied the 4 and the 2. Let's take a look here. We can kind of do the same thing here, not with the s or the r, but with the t. So we're going to get s, t to the 4th, divided by r, and then we distribute the exponent, that's 2, through for everything. All right, this one becomes very complicated. But first we're going to get rid of and see if we can simplify what is in the parentheses. So 36 divided by 4 is 9. A to the 5th minus a to the 4th is 1. And b to the 8th minus b to the 5th is 3. Then we'll distribute the 2, and then we get our answer of 81 a squared b to the 6th. Okay, what other rules do we have? We have the negative law of exponents. If the base is powered by the negative exponent, then the base becomes reciprocal with the positive exponent. What does this look like? All those words really mean if you have a negative exponent, then you're going to turn it into a fraction. Okay? Here we have two examples. Notice that if we start off with 5 to the negative third, it becomes a fraction of 1 over 5 cubed, which is equal to 1 over 125. However, if you start off with a negative exponent in the denominator, it flips up and becomes a positive exponent, in this case 3 squared, which is equal to 9. So when you have a negative exponent, you switch the base to its reciprocal with a positive exponent. If the base with the negative exponent is in the denominator, it moves to the numerator to lose its negative sign. What other laws do we have? We have the zero law of exponents. Any base power by 0, exponent equals 1. So it doesn't matter what it is, x to the 0 equals 1. Here's in it some examples. So 5 to the 0 equals 1, a to the 0 equals 1, and if you have 5 times a in parentheses to the 0, it too equals 1. So 0 factors of a base equals 1, and that makes sense. Every power has a coefficient of 1. Let's take a look at a few more examples. So what would the answer be here? That's right, it's 1. What would this answer be? Notice that when we add them together, you have a -2, and we always express exponents as positive numbers, so then it becomes its reciprocal of 1 over y squared. What about this one? That's true, it just becomes a reciprocal. What are we looking at here? All we have to do is add them together. 7 minus 2 is 5, so you get 4s to the 5th. What about this one? So they distributed the -4 to everything. Then whatever was negative, they reciprocated it to the denominator, and then they took the 3 to the 4th and made it 81. What about the answer for this one? That's right, it's just 1. Just a few more. Okay, if you have a -1 like this, then all it's going to do is flip it. Okay, again, we can take 3 to the 9th over 3 to the 5th, that becomes 3 to the 4th. And then if you distribute the -2 in there, that's 3 to the -8th, which means you have 1 over 3 to the 8th. Here we can simplify both s's and t's. And when you distribute the 2 through, the -2 through with the -2's, they will become positive. And here we have one more. We're going to take 36 divided by 4 is 9. A to the 5th over a to the 4th is just a, and there is no b on top. But then they take the -2 and they put it through. So we get b to the 10th over 81a squared. Thank you for your participation, and that is your review of exponents.